Hello everyone and welcome back. So this time we're in chapter 6. We made it. We're in chapter 6. Who would have guessed? So what we're going to talk about today, well, we're going to understand how torsion deforms solid bodies. And we're going to be able to connect the shear stress with the angle of twist. Shouldn't be deflection, it should be twist. So let's get into some applications today. So first off, engines are increasingly moving towards greater levels of electrification. Now, these electric vehicles, they actually have higher torque than many traditional engines. As such, we have to kind of worry, well, are the shafts going to be able to take this increased torque? What's going to happen to them? Because, there's resistance from the road, and then we have the engine turning in the opposite direction. Will it be able to overcome the resistance? Will the material be okay? So we really need to figure out the stresses that are caused in that arm by this torque and understand what it's going to do to them. Now, torque is a common word. You might have heard it when you think about cars. But what it is it's a tendency to twist an object by its longitudinal axis. So it's a moment that tends to twist an object by its longitudinal axis. Now, if we want to transmit this, we usually use a shaft. You might also use things like a belt or gears to transmit torque, but normally it's a shaft going from one source of torque over to the wheels. Now, in this class, we're going to limit our studies to sections of shafts that are like this one right here, away from any kind of crazy changes and nice circular and cross section. We want to do this because by this point, the stress distribution and the strain distribution will have normalized. Now, one interesting thing you might not realize is that when it comes to these circular shafts, there's some very interesting things that you can see if you were to put lines along the edge here. So you can see we have these parallel lines that are going along the longitudinal axis. We have radial lines that are going against it. What we realize is that if we have a circular cross-section, then a plane beforehand, like one of these lines right here, and a plane afterwards, they are still planar. They're still, they haven't changed, they haven't deformed, there's still these nice flat cross-sections and they're still parallel to each other. And all those radial lines stay in the same plane. So they were in this plane beforehand. I'm looking at it from the side now, but if I'm looking from the front, this would be the radial lines. And afterwards, they're still in that same plane. However, this is only true for circular cross-sections. So we're only going to limit our studies to circular shapes. There are some rules of thumb and some equations for squares and other things, but as you can see, that's a nightmare. Let's avoid that if we can. Okay, so that's all for today. Just talking about this introduction here, how we're going to be having torque that's going to twist things. And we need to understand how it's going to affect the stress and strain distribution inside of our shaft. So thanks for listening. I'll see you all next time. Bye.